So Mark, really appreciate the opportunity to sit down today, and especially appreciate the opportunity because, as we were just talking about, you're on and off of planes and on and off of calls. So I know the time we have is a fantastic chance to speak. Now, your career is one that spans really the cutting edge of technology and the cutting edge of motor racing, from McLaren to Arrows and Super Aguri and many others, as we'll get into. To begin with, it would be really helpful if someone was trying to ask you to summarize your career or summarize what you've done in your journey in just a minute or two. How would you convey that?
Yeah, thanks for having me today. Yeah, trying to summarize it in one place. So I'm from Australia, so came over here to the UK more than 20 years ago, with the single focus of getting to F1. We had F1 in Australia. We grew up at university and school watching F1 and some of the drivers back there, and realized, I think, pretty early on that I suppose I wasn't going to be the actual fast driver, but I could be the engineer that made the drivers fast. So, and to compete on the world stage, the best place to be was in the UK and in F1. So came over here and worked for Arrows, McLaren and others along the way. And then at one point did an MBA at Oxford, and sort of started to go from the very technical side to the more business side, and then started a Formula One team with Honda and Aguri Suzuki. And then after, sadly, Honda pulled out from the financial crisis back in 2008, then moved over to electric vehicles, and then over the next 10 years worked in Formula Electric, and won multiple titles in that series with car companies like DS and now with Yamaha in the series. So been a sort of a long journey, but always focused on motorsports and really learning actually the whole time.
And you said initially the initial aspiration perhaps was to go fast yourself on the track. Did you ever have any actual experience? Did you do karting? Did you?
Yeah, so a friend and I bought a go-kart, and I found out pretty soon that I could make him faster than he could make me. So therefore, I focused on making the kart fast and really just got into let's win rather than me being the racing driver. And so that sort of carried on through my career.
And as soon as you figured that out and you understood that, clearly your passion was in initially the world of engineering. You saw that as the route to the pinnacle of motorsport.
Yeah, so I suppose if you think about the kind of the T type idea, I was a stress engineer in simulation and software, so very, let's call it deep on the vertical, let's call it in simulation and calculations, and that's what I did early in my career at also GM and other places. So I was always did the design of the simulation of things. And then as I did my MBA, then sort of become more broad when you get older, I think. So when you start out of university, it's like, what can you be the expert in? And that's what my expertise is in. And funnily enough, still use it today when I probably annoy the engineers a bit much by asking certain questions about simulation and things like that. Maybe I don't ask as many questions about the areas that I wasn't the expert. But yeah, now I get to be broader as I suppose you get older.
And you referenced before a very nice line, which is that your career has really been about learning. And even just in the couple of minutes that we've started speaking now, clearly you've moved across a variety of different domains and a variety of different areas of expertise throughout your career. Is learning the red thread that connects all of them?
Yeah, I think so, because I think I get a bit bored when I'm not being challenged. And I think I noticed over the years that whenever the next thing was coming, and whether that was early in my career with crash analysis, we did the first analysis ever, I think, in Australia. And when we've done things in Formula Electric, it was the first race cars that were properly electric. I remember in the first year of Formula E talking to some sort of ex-colleagues at one of the big groups, and I said, so what's the answer to this thing? They said, we don't know. It's the first year everyone's been doing this. You tell me. And it was kind of fun being on the very bleeding edge of things where no one knew the answer. And I think I've always enjoyed being on the absolute cutting edge, bleeding edge, where it's better when nobody knows the answer. It's more fun, I think, certainly for me, because then you actually have to figure it out, how this thing's working and what's going to happen. And I find in motorsport that even when you think you've got to the end of some development, then it opens up a whole different area that you didn't think would open up, and you start to go down a kind of rabbit hole in a new area of development. So it's always pushing the boundaries and always learning and always being on always better to be where everyone says, I don't know. That's enjoyable to me.
Yeah, definitely so. And I think elite level sport as a whole, and obviously, as we said, my background was in tennis, but broadly speaking, elite level sport is generally at the leading edge or the cutting edge of technology, innovation, whether that's related to the human body, whether that's related to equipment, whether that's related to tires and cars and suspension springs, whatever it may be.
Yep.
And Formula One in particular, or motor race in particular, is of course a huge driver of that from a technological standpoint. What did the experiences that you had at organizations like McLaren and in Formula One and Formula E, what did that teach you about leadership, about strategy, about management that you think that those in a more conventional management or strategy setting may not experience?
Yeah, I think winning, pushing things to the absolute boundaries every 2 weeks in F1, certainly Formula E, sometimes different times. We're off racing again in another week's time. There's not much time in between things, and so when you're I've worked at GM and other places. Let's call it in the normal world. Sometimes times can change. The delivery time can change by a day or two, but in motor racing, the race goes on without you. So you have to look at things like time boxing and saying, in this time frame, what can we do between now and when the plane leaves next week to go to the next race? That's all the time we've got, and then we have to, whatever we're up to at that point, that's what you have to use going racing. And I suppose it's the same in tennis or anything. You've got to be training to a certain date when you're going to be playing or driving or competing in that respect. So I've certainly learned a lot about have to make pragmatic decisions, time boxing things. I've learned later what maybe was the technical word for something like sprints. We didn't know it was a sprint, but we just went, you've got till next Friday to decide this thing, and that's it. On that day, you release the software, it goes on the car. That's all you can do.
Technical term or not, does it really matter? I mean, you need to get it done. You need to get it done.
Yeah, so that's certainly one of the high pressure parts about motor racing, and as we said about any sport, because even if you're training to, say, tennis or football or something, you've got till that date, and that point you've got to deliver and see where you got to over the last couple of weeks or days, I suppose, in some sports. So it's multifaceted, and there's certainly lots of areas I've had. When I did the MBA, I sort of tried to find theories and concepts from that MBA that I then realized, in engineering, this is kind of how to link the let's say the terminologies together. An example would be that there's a lot of race teams here in the UK, and you would say it's part of a cluster. And if you look at Silicon Valley, that's a cluster of startups and obviously tech companies. And that sort of shows you, if you ever start a motor racing team, put it in the cluster, which is here. You can do it outside the cluster, but it is harder to run a team in Italy or others, although maybe that's changing. But certainly the majority of race teams are in the region of the sort of Silverstone area. So things like that, where you can actually put a terminology to it and understand why it's beneficial to do a certain thing from a more, technical term in terms of the business side, rather than just the engineering side, which are, looking at science and physics and that kind of thing.
Yeah, absolutely.
But looking at it's the science of strategy, etc. I think the other thing I learned, probably the big one, was at going to McLaren, was that the just level of professionalism that Ron Dennis had put into the place, and is still there obviously now. They never really went backwards. They embedded the knowledge in the company. I think in the previous teams I was at, maybe we would not bother writing something down. We'd do it, and then we'd come around the next year and say, "What did we do last year?" Whereas you would go to McLaren, it's like, no, do it properly, write it down, embed the knowledge in the company, and then when somebody needs to know, just go back and look at what was written down, and you sort of don't go backwards. So I learned a lot at McLaren, just making everything about a science, making it not black art, making it about everything understood, written down, and then you sort of don't go backwards. And I think at other teams we've been like going backwards, and how can you ever catch the guys like McLaren if they're always going forward in one direction?
Oscillating more than
than going forward.
Yeah, exactly, than going forward. And just out of personal interest, there's the story of Ron Dennis at McLaren. I think it's seeing a phone on the wall that's slightly off center and essentially ripping it off and saying, no, put it back in and make it right.
Yeah.
Is that just a nice anecdote that someone like me sees and reads about, or do you think that's actually a core part of an organization embedding a values and ethos of professionalism and structure?
Yeah, I think that's what he certainly brought to McLaren was perfectionism. Making everything perfect, making it quality. I think when I first turned up, I was trying to see the differences between having worked at Arrows and what was McLaren. So I was kind of back to backing, of course, everything, trying to see what the differences were. And a lot of it was to do with the professionalism. It was at another level, and it had come from probably a longer term team. So Arrows had sort of chopped and changed over the years, whereas McLaren was the same group. A good example I remember was at Arrows, I think we changed engine manufacturer 5 times in 5 years. And at McLaren, they had the same engine for like 10 years, and I think they probably still do now, actually. The Mercedes, I'm not sure if it's gone through the whole time period, but you suddenly realize, at Arrows, we redesigned everything every year. Whereas at McLaren, why would you redesign that bit that actually works? And it was one of those things where it was like a business thing overlaid on top of an engineering problem. And you're like, oh yeah, the stability really did benefit McLaren. At Arrows, having to change it, and it wasn't just sort of the new engine; it was also getting to know people.
Yes.
So I've also noticed that if you have a new engine manufacturer partner, every year you've got to get to know them all. You've got to understand everyone's strengths and weaknesses. You can start to work to those strengths and weaknesses, but then change again. Whereas when I was lucky enough to work with DS in Formula E for how many years was that? I think it was 5 years or so. And so it took us all a while to get to know each other, work together. But then once we were winning. We won a couple of times in a row together. And so that stability is amazingly important. And you don't realize that when you sort of think it's not all about macro things. It's about engineering and bolts and nuts and everything. But it's actually a lot also to do with just organization, people, getting to know each other, working together. I was quite surprised at some of those things that weren't engineering.
Yeah, definitely. And I think it's fascinating because when you look at any organization from, as you were just saying, a Formula One team or a Formula E team through to a football team, you've got all of these different components. For a Formula One team, there's engineering and operations through to the commercial side of the business, through to the drivers, through to the relationships, and it's similar across many other areas as well. And the benefit of continuity, I think, is very true in strategy as well, to bring it back to the business side, because in strategy for so many organizations, they get that knock on the door in September and someone says, okay, strategy time. They sit down, they hammer out this new strategy deck that might be a big document like this, and then it kind of sits in a drawer for a period of time. Yeah. Whereas the reality is, it's so much more effective to build off of what you've done the previous year, to leverage what's come before, to iterate and adapt and refine, as opposed to say, okay, let's start again and let's build something out.
Yeah, there is a balance though, isn't there, about how to push forward. Certainly when I joined McLaren, it was at a time when Ferrari was quite dominant. And so part of what happened with it's called a MP418A, it's the car that never raced. And it was meant to be a big push to see how we could catch Ferrari. It turns out it wasn't really the way that we did catch Ferrari, but it was tried to do something like over the edge in every area, and that's where I got to work with Adrian Newey and learn how he approaches things, but perhaps the organization wasn't quite ready for that dramatic change, and then obviously they're being successful at the moment, so then that was maybe too big a change, and maybe it should have been a little bit more incremental. But then on the other side, I suppose every so often when the rules change, you've got to deal, you can't be too incremental, so that's a balance, isn't it? Because if the rules change, which they're going to next year in Formula One, it's going to be interesting to see who gets it right in 2026. We're in 2025 at the moment, but what happens in 2026? Who makes a sensible jump in all areas?
And that's quite a unique constraint and a unique construct to motor racing, right? Which is, at least in Formula One, every single year, you know that the regulations will change, whether that's related to diffusers or double diffusers in the past, whatever it might be. Yeah. What have you learned from that environment in which you'll be racing in a season and you need to be focused on how do we iterate, how do we adapt, how do we improve within this particular season, because there's a lot on the line.
Yep.
We know that the regulations are changing for next year. It's an opportunity for us to develop for next year. How do you balance that? Because it must be a very tricky balancing act.
I suppose just trying to think of something that's changed over the years, but let's say processing power or something where in the current car we've got a certain amount of capability from the hardware side of things, but we've recognized we're coming up against some processing capability or data transfer rate or something that's limited by a piece of hardware because our cars are homologated in Formula E, so the hardware is set for 2 years, but the software can change all the time. So we're developing software, and then we're perhaps come up against a hardware limitation. So we say, okay, we can't do anything about it now, but in the next iteration of car, let's change that thing that allows us to go further. So maybe you're limited right at this minute. We can't make that change, so we have to just do workarounds in a way. And then knowing that when we're able to change the hardware in the future, we can say open up a whole different area of development based on where we got to in say this car.
Which I believe comes back to your original point, which is in an environment which is adapting so quickly, changing so quickly, and also sometimes can be quite uncertain. If you come at it from a place of stability with the suppliers that you work with the foundational elements you put in place, I imagine that's got to make things much easier.
Yeah, just even getting to know, so like developing a specification or an understanding of which direction we're going, it's surprising how long it takes everybody to be on the same path. Maybe going back to your point about, you do a new strategy document, then everyone's got to learn what they've actually got to do with that document. Same sort of true of, if you go and work with go back to the Arrows example, a new engine developer, then you've got to understand their philosophy. Are they about maximum revs? In the old days, it was more when there wasn't restrictions on RPMs and things. It might be they wanted higher revving, more peak power, and maybe a different company would go for sort of a different torque curve in the engine. And you had to sort of understand their philosophy, why they did it, what that meant to the fuel systems and all sorts of things on the car. And then you'd sort of get your head around how they'd approached it. That might take a little bit of time. And then you obviously get into the racing, and then you start learning together about how the two systems fit together, engine in this case, and race car. And it might take a few races to figure out, okay, the engine works better like this, or the car reacts badly in this way, or something in particular. But then if, like Arrow's days, you change engine again next year, you've got to go back and learn it all again.
Yeah.
So it's amazing how long all that stuff takes. Just, as I say, getting to know people, understanding why they do things, how they do things, then looking for not loopholes, but maybe, okay, now we understand why you do the engine that way. We should have maybe done, the fuel system this way because we didn't realize that was what you were targeting. Okay, now understood. Next year we'll do the different fuel system that works with your engine or something like that. And so it takes an iteration because one of the interesting things about sort of hardware and software is obviously hardware takes longer to iterate on. And so software can iterate fast. And that's certainly something that's coming in road cars and more in race cars is that software can iterate fast, like on our phones.
Yes.
And the hardware is maybe not as fast to change. And so there's a balancing act between the hardware upgrades and the software upgrades, which can come super quick.
And if we're speaking about commercial vehicles, I imagine the lifespan of which the hardware is designed for is typically much longer than the lifespan that a piece of software is designed for.
Yeah.
So you're rubbing up against that challenge.
Yeah, exactly.
So to come back to the unique nature environment of a motor racing team, when we think about the value chain of a motor racing team, it's quite complex, and you have everything from supply chain and your suppliers through operations and manufacturing, all the way through to relatively complex HR and finance that's required to run a motor racing team. And you also referred to the challenge of the macro versus the micro. So you need to be able to oversee all of that from a macro standpoint, whilst at the same time, at least relying on your teammates, your team members to be focused on the absolute micro, whether that's a fuel injection system or whatever it may be. At the same time, what we see or what I've learned having these type of conversations and work with organizations is the biggest challenges of building strategy and executing strategy around clarity, so not a 200-page document, accountability, so people actually understand the role they play in the strategy, and also execution. enabling people to go and execute. How do you manage that? What have you personally put in place or learnt to ensure that those that sit within the organization have that clarity and have that accountability to go and execute?
Yeah, I mean, the good thing about sports is that there's obviously every 2 weeks as such, you get an answer to your question about the performance. So the biggest KPI, are we quick enough? Are we reliable enough? Have we done a good job at the track? Is the pit stop quick enough? And all those things. So at the racetrack, it's a lot of the KPIs are tested every week, and it's kind of obvious to the world, I suppose. But in behind the scenes, that the kind of important things for troubleshooting and things, we have like faults list or snags list, they call it, which is every single little thing that's gone wrong. It's not blaming anybody. It's just saying this went wrong. What should we do next time? Very pragmatic. Yeah, and so you have a big list that's reviewed every week, every day, that people can go in and say, I'm just trying to think, the pit stop didn't work because the wheel gun didn't work for some reason, and that would just be wheel gun didn't work kind of thing. And then a group would be like tasked with going and figuring out why and what could we do and how quickly could you get the next upgrade and what's the workaround for the next race if we can't get the new technology or whatever's required that race. There might be we noticed the way you do X, Y, Z could be okay for the next race, but then when the next bit of technology comes, it'll fix that problem. So that kind of rigorous looking at the problems, and then say every 2 weeks you get an answer to your questions. Communication is obviously massively important to make sure everybody knows what is important. So lots of kind of reporting and things internally, so that you get down to everybody understands that what's important in their area. I remember an example once where somebody who ran one of the machine shops, I think it was, said, but I can't have an impact on the problem you're having at the racetrack. And I said, well, you can though, because the speed at which you can do the next hardware implementation will mean that perhaps we can have that at the next race. And if you can get it done quicker because you've got an idea about some way of working in the machine shop, then we can have it quicker on the car and we can solve a problem. So the speed at which you can do things because of the way you're doing things can have a direct impact on the car. And they sort of hadn't thought about the fact that they actually could have an impact on the car. Harder to see it, but it just having a faster machine shop or a faster such and such in the group meant that ideas could get quicker to the race car, and then the problems can get solved more quickly. So communicating that everybody has an important part to play, and so they can also see what they need to work on is quite a hard one, because I think sometimes you can be thinking you're doing the right job and you're working away on what you think everybody wants you to do. Yes. And if there's no communication to say, hang on a minute, the most important thing is over here now, that element is either being solved by something else or it's dropped in priority because now there's this bigger thing on the horizon, a rule change or an update or a problem we've had on the car, or actually we can go faster if we now do this. So communicating through the organization what's important and when and why, and then obviously at the racetrack the KPIs are, did we go faster, what's the pit stop speed, there's all sorts of little wins you can have everywhere. And I think that's actually one of the ones that I've noticed translates well outside of motorsport, in that where can the little wins be. So in the I think it's the Tour de France team, where they talked about how they changed pillows so that the riders got better sleep and all of that. I think that kind of thing also translates well outside of motorsport, where someone might say, but I haven't got a lot of money in my department. It's like, but where are all the little things you can find that can make a big difference?
It's the epitome of marginal gains.
Exactly, and they're just everywhere. And so we often had a thing where we'd say we bring 5 new things to each race. Now, one race, it might be a big engine upgrade, but the next race, it might be just changing the way the coffee machine works, or something that that everyone's getting annoyed with. that's frustrating people. So you could, or the food's terrible, or something that could be maybe simple, but it didn't cost a lot of money, just asking a different question.
Yeah, definitely.
But everyone likes the engine upgrades, but there's tons of other things you can do every day.
It's the classic iceberg, right? Everyone sees the tip of the pillar. They see the Formula E Championship wins. They see someone on the podium holding the trophy, but the reality is it's all of the little components over days and weeks and months and years that ultimately lead and drive that
I remember we had a silly one where, it's not silly, I suppose. There's these lifters that lift the cars up and down.
Yes.
And where in the first year of Formula we didn't have enough budget to have more than 2 sets of them. No, we had 1 set of them, I think. And when we got 2 sets, the mechanics were like, whew, our day just became like 15 times easier. And like, why is that? Well, you see how heavy these things are. We have to drag them across the garage, and now we've got 1 each. And it's like, yeah, I suppose I hadn't thought about how much of an impact that could have. So sometimes something that doesn't seem like it's important suddenly goes, okay, now our whole day changes, and now we can do more of X, Y, Z. And that only costs £10,000. It still sounds like a lot of money, but
in the grand scheme of things, when it comes to motor racing, it's costs a lot to go racing, right?
Yeah.
And just to close the topic a little bit on motor racing in particular, I imagine your role, and I know you've had various roles over the years, but really leading teams, whether that's as a team principal or whether that's in another leadership position, you also need to keep everyone focused on the longer term ambition of where are we trying to be as an organization in 3 years' time, 5 years' time. And as you said, at the same time, you're also receiving this input and feedback, and there's nowhere to hide because every 2 weeks it says which position you finished, it says what your fastest lap time was, it says these KPIs and these KPIs. So how have you found an effective way to manage that, and also to galvanize people and get people to understand in the long term, that's where we're trying to go, that's what we want to be?
Yeah, so in this first season of Lola Yamaha, so we've only started working together. Well, in the background, we've been working together for like 2 years to get the powertrain ready for this season. So this season, we're working as Lola Yamaha Apt, which is the race team. And again, those 3 groups, first time they've worked together. We're now 10 races in, I think, to our first season. But we're up against Porsche, Nissan, Jaguar, who've been doing it as a group for more than 5 years, each of those groups. So we have been looking at what are our realistic KPIs, but also trying to push ourselves, each other. So we've not said, okay, we're going to win the first race. But what we have said is there's a thing called duels, which is the way the qualifying system works in Formula E. You do 2 qualifying sessions, and then the top 8 go into this thing called duels, and it's like a round robin. And so we said, okay, in some ways, getting into the duels is a proxy for performance. And so we said, okay, target every race, one of the cars getting into the duels, and then every race try to get both cars to get points. So that's a good step for us in our first season. Then we also actually went above that. We got a podium and we came second a couple of races ago. So everyone's like, okay, what's the next goal going to be? Because now we've got on the podium. We didn't have that on our goals. The longer term is obviously we want to win and be targeting wins, but we're also not unrealistic about who we're competing with and how fast we need to catch up. So we are coming sort of more quickly than, of course, the others because we've got more to learn and more things to catch up with. But I think those goals are good goals for the first season. Scoring points is really important, but always going on like a positive gradient. One of the engineers who used to work with me was like, yeah, we're okay this weekend because we're still going on a positive gradient. If we were going backwards, then that would be a different story. So always on a positive gradient, heading towards obviously the winning races. Again, for actually all the groups have won races in the past in different series, and so getting back to that is important, but also not being saying we're going to win in the first year, otherwise we've failed, because that doesn't recognize who you're competing against. So I think we've got a good path, and we're surprising ourselves all the time with a bit stretched targets each race. But yeah, looking at all those KPIs, not always maybe just the win KPI, but could be the fastest lap, or it could be the quickest pit stop, or it could be the nicest looking garage. There's lots of things that can be you can win in terms of KPIs. So also looking around at all those things as well.
Similar to a business is that it's, I imagine for a motor racing team or as a tennis player, it's very easy to get fixated by I need to win, or fixated by I need to have the fastest lap, that the big sexy overriding target. But at the same time, like for an organization, if you get fixated on revenue or fixated on gross margin, there are other KPIs, as you were just saying, that feed into that for a business, whether that may be how efficient are we being from an operational standpoint, how do we take care of our people, what do our customers think about us, all the way through to the environment, for example. So it's interesting to hear you speak about different KPIs and also describing, as long as we're moving forward, as long as we're progressing, that's positive. And my first tennis coach, when I was 3-4 years old, used to say that when you zoom out, you want it to look like this.
Yeah.
But when you zoom in a little bit, you'll realize that, okay, you may be trending in the right direction, but the reality is it's like this.
Yes.
And as long as it's still trending positively, and when you zoom out, it looks like that, that's great. But you need to understand that it will look like this.
Yeah.
And sometimes those troughs will be bigger, sometimes those peaks will be higher, but generally need to be trending in the right direction.
Yeah.
I think that's always the case.
I suppose it's in a more mechanical systems-based thing. The other metric in this is reliability. So not so much, I suppose, being a tennis player to an extent, I suppose. But
I've got some wrist surgeries and knee surgeries that can attest to that. But
okay, so the quality. My uncle used to say is the quality system is if you're pushing a rock up a hill. The quality system is the wedge you put under it every so often when you want to stop for a minute, kind of in a way.
Yeah,
so
definitely.
the quality system, you push the rock up a bit, you put the wedge, you push that up a bit, put the wedge, and so that you don't keep slipping backwards all the time. Now, it can play out in different ways, but it's quite amazing how also motor racing, and I think probably any sport, a lot of it is about just perfection of every single thing. You know, as everything from the food people eat when they're away in a different country, maybe somebody's not the best at eating spicy food or something like that, and you go to another country, maybe you need to make sure that person has the right thing to eat available because you don't want to upset their body, let's say, when they've traveled to another country. It could be something as simple as that, to getting the right sleep perhaps, and not working people all night, which maybe we used to do. Nowadays it's a bit more curfews and being sensible about how many hours people can work in a day. But some of these little things can also balance out.
I still like the idea of a mechanical engineer under a car at 4 a.m. But maybe
been there, done that.
Yeah, I haven't, but I like the idea of it at least.
Yes.
Now to shift a little bit away from specifically from motor racing, because as I alluded to at the beginning, you're very, very busy and your time spans a number of different areas, and there are other steps that you've taken in your career still within the same sphere and industry to an extent, but not in motor racing. Could you maybe just speak a little bit about that and what you moved into, as well as the reasons that you took those steps?
Yeah, so I've got involved in some startups over the last number of years. One of the things I did out of off my MBA was I was interested in trying to work in some startups. So I did help a couple of spin-outs from Oxford University. Oxford Yasser Motors was one of them, which helped do the business planning and things for at the beginning to understand how the startup world worked. Then got involved in autonomous vehicles. So that was a kind of a startup in terms of it's still in the same area. So in automotive, trucks happened to be the one we ended up in, but funnily enough, my first job out of university was designing trucks. So come back to that after 20 years or so. So autonomous vehicles, the cutting edge of software, understanding how to run autonomous vehicles in this case in ports and other areas, but also just getting involved in the whole startup mentality, understanding how you do start up something. Got to start up the Formula One team with Aguri Suzuki, and then took those learnings over to starting a composites company after Honda pulled out of F1, and then so learned a lot about starting a company from scratch. But we were still working in Formula One, but now I was a supplier to Formula One teams, so actually saw it from the other point of view, thinking, oh my God, those designers, why did they do it like that? Whereas you'd been on the other side previously. So learning from being part of the supply chain and actually starting a company from scratch, learning how to do sales, learning how to do just everything, accounting, all the normal things that you have to do in a startup. So I've had that kind of parallel experience, which has been fascinating in terms of learning how you do startups. So that's been absolutely fascinating.
And specifically on the topic of autonomous vehicles, when most people, or at least a lot of people, think about autonomous vehicles, they think about the advancements that Tesla are making and autonomous taxis and self-driving cars. Why specifically did you and your colleagues focus on or become so passionate about the problem you're trying to solve with autonomous vehicles in ports?
Yeah, so we were looking at basically the kind of utilization of a vehicles, and when you look at ports can run up to 24/7, so that means the utilization of the vehicles, unlike say a robo-taxi, which theoretically when you look at when people want to use taxis, it's in the morning and it's at night at the normal time everyone wants to go from home to somewhere, and so the utilization is different. It's peaks. It just sort of runs from whatever time the ship arrives in port till when the ship leaves the port, it's running flat out the system. So we found that to us looked like the best use case. It's also off highway, which means that it doesn't require the same levels of sign off as running in a complicated place like downtown London where we are. So that's a lot different than running in a port where it's private land and running under private rules effectively. Still road rules, but running slower, running in known areas, in controlled operations. We've also got some trucks up at Nissan where we're running again. It's in a private space. Even though there's vehicles from outside, it's still run privately. So taking away some of the big boundaries or barriers to entry for getting the vehicles running. So yeah, one is just running more utilization, therefore over longer periods the trucks can run. And yeah, slightly simpler than running on roads. Still complicated, but you take away some of the variables that you have to deal with.
And with that in mind, was there a particular problem? We spoke before about pains. A particular pain that you were truly trying to solve, or a number of pains?
So when we started, it was called Street Drone in the beginning. We're now part of a bigger group called Oxford, and we actually took a lot of our motorsports knowledge into doing the first vehicles. So some of the first vehicles we did, we actually took some of the learnings from doing a Formula E car across into those vehicles. So we started in the area of like what they call drive-by-wire. So actually the thing that let's call it the brains can control the car with. So that's how we started. And then as we've moved into working inside of Oxford, that's very much a software-driven business. And now we're looking to push some of those, work with others to put the drive-by-wire into some other OEMs' vehicles, and we're working currently with Terberg, which does the trucks with us in the ports, and so working closely with some of the people that we develop knowledge with there.
And clearly it's such an incredibly fast-moving space and such a pertinent space as well. Are there any commonly held myths or commonly held beliefs that people have around autonomous vehicles, or sometimes concerns that are misconceptions?
It's a fairly complicated thing. If you've been in a Tesla, you'll see some of the, you can be running on, I haven't run on FSD, but certainly just even lane keep assist and those type of things. There's still a lot of edge cases that you just don't expect to come up. If anybody's been running any car actually, I've found it in the VWs and others where if you're going down the motorway and all of a sudden it slows down, you think, why is it slowing down? And it's because it's got data from perhaps, I'm not exactly sure when, that corner needs to be taken more slowly, and you can't see any problem, but it's slowing down thinking that it's not allowed to go faster in that area. So it's still complicated, still a way to go, but quite an experience if you get to go for a drive in say one of the Oxes up in Oxford, or perhaps a Waymo in America. There's still a lot of problems to solve, but mostly it's about the edge cases, the things that are just not normal. So let's say a port, suddenly it snows, then we'd probably have a bit of a problem there if it snowed in the port. You'll see that a lot of the trucking and stuff in the US are in the sunnier states. So there's less variables at the beginning. So it's always about minimization of variables, I suppose, when you think about it in comparison to motor racing. In some ways, a car running in a racetrack is actually a cage robot in a way, because you're going one direction and you've got cage around it, which is the fences, and you've got a very big set of rules which say you can drive down pit lane, but you can't really do much else. So actually the variables are you've limited a lot of variables in the racetrack, which is why that in the early days there was some things like Robo Race and other things in autonomous leagues in Indy and in Abu Dhabi. So still playing around with racing cars and autonomy as well.
And of course, AI and machine learning and the whole spectrum of that field is hugely topical from what we're doing here to the work that you're doing. What's the impact of that, both on the motor racing side of things, but also looking at autonomous vehicles? What are you seeing?
Yeah, so the machine learning aspect is probably the best one to think about is in what they call the physics informed models. So you're trying to correlate, let's say, tires, which is one of the biggest challenges. Maybe that one's a bit too complicated, but you're trying to correlate a physical model. The more data we have, the processing power that we have nowadays, you can use machine learning to parameterize some of the areas that would have taken by, let's call it by hand, a lot longer. I started to do genetic algorithms like 20 years ago, 25 years ago now. And what's changed now is more data, more processing power. Obviously, the industry has learned a lot from Google and everybody over the last 10 years or so. So there's lots of problems that we're trying to solve or looking at solving with machine learning and then AI at the moment in motor racing. Some of them probably a little bit too secret, but yeah, there's certainly a lot of areas that we're experimenting with in machine learning, and because there's so much data off the race cars, and also so much data we have as a manufacturer. So because Lola Yamaha is the manufacturer of the powertrain, we have test cars and dynos and other rigs where we're trying to learn as much as we can and then apply that to the race car. Mm-hmm. Same is true in autonomous vehicles. More data, because it's also video, which is a huge amount more data with video, lidars, and other things. So it's becoming, or already is, very, very important in those areas. You'll see there's a lot more discussion about end-to-end learning. So can you get to a point where the autonomous vehicle can just learn like a person? Now, maybe it's not quite there yet, because you've got to teach the car so many edge cases and things like that. I don't think that's quite there yet, but it may be what is the final solution, yes, perhaps in the future. So certainly moving very quickly.
And are there any industries which potentially haven't been touched as much by autonomous vehicles or autonomous systems, which are a little bit more left field, that you'd maybe place some bets will become more disruptive moving forward?
No, I hadn't actually thought about where there might be places that we, let's say, haven't looked at, because it's already in places like mines and agriculture, yes, and those things where it started in those areas because that's where the variables are a little more limited. So I think driving downtown in London, for example, or Shanghai or mm-hmm. Tokyo, or maybe not Tokyo, that may be a little bit easier than maybe let's say if we took Delhi or somewhere like that, wherever it's more chaotic, that'll be still a little way off.
Yes.
But in wherever there's more control, less variables like sunshine and rain and snow and those kind of things, that'll be the places that it starts first. Where it's being developed now. And the left field sides, I don't actually think there's probably any areas that I know of anyway where I haven't seen it. In Shanghai just recently, and the robots that go around the hotels, and they're sort of already going into so many different areas. Drones, all the things that are happening at the moment in sort of the drone area. So I think most places are being experimented with, and I wouldn't say I could tell you right now a place that we haven't that hasn't been touched yet. It's certainly being experimented with anyway.
And just from your viewpoint, or from where you're sitting, does it excite you, the rate of change and level of progress? If we talk about autonomous vehicles or AI, does it scare you a little bit?
It's certainly we're trying to play with it all the time, and I think some of the best advice I can see at the moment is you just got to get into it and try to understand where it's beneficial. So, for example, I get quite a lot of reports from the engineers, and so and then rules and minutes from meetings from rules and everything. So you can imagine I'm sort of putting it into a notebook LM and saying, okay, give me a summary, give me a podcast. One of the things I found quite good is you put some documents into the notebook LM and get you to do a podcast, which you listen to on 1.5 speed, and then it finds things in the document, and you think, oh, that's interesting. And then you go in and dive in and find out, oh, okay, I didn't realize that thing had happened. So I suppose it's like trying to use it, at least at the moment, to filter down all this knowledge to something a bit more succinct. And then you can go and look in the details just to reduce time. And then I do find it's quite good at sort of just brainstorming things, because a lot of the things that we're doing is technical, and because it's based on so many papers and scientific literature, then it does find things that you just didn't know probably that existed, which is part of the battle. I think when I started to do engineering, you used to have to go and look it up on a catalog, and then someone was saying to me, go to a microfiche, if anyone knows what one of those is, and then look at the microfiche and read it, maybe get it printed out, and then, whereas now you can just say, I'm assuming that one of the LLMs has read all of those papers and give me a summary
on it. Yeah, exactly.
And tell me where to start.
Exactly. The podcast idea is an interesting one because I use it a lot to condense documents and emails or strategy documents, for example. But the podcast idea is interesting, and it is very good at that in particular, or finding areas of convergence or divergence in conversations. The dangerous part is when it hallucinates and basically just makes crap up.
Yes.
That you need to be cognizant of. But as you said, it's a learning experience.
I think it happens in motor racing quite a lot. It's that thing where it's outside the bell curve, basically. It's as soon as you get outside the knowledge you have, then it starts to get worse. So I think it's the same as anything. It's when you ask it to ask things outside of, I don't know, Six Sigma or something, then it's like, I'll have to make this up because I don't know the answer either.
And like anyone else, it doesn't want to appear not to know. So why not give it a stab?
Yeah.
So in terms of your career, just to bring a little bit full circle, spans from Formula One to Formula E to autonomous vehicles to a number of other areas that we've discussed. Is there a consistent leadership lesson or a pillar of leadership and strategy that cuts across all of those?
I think I am quite science-based, and therefore I learned quite a lot from the people I've worked with over the years. So I do try to bring it back to sort of scientific, know your numbers, have a scientific numbers element to it, simulation, modeling. That's, I suppose, not so much leadership, but sort of saying everything should be about, like I learned from Ron Dennis, make it into a science, don't make it a black art. So too much where there's somebody guessing something and there's not really based on enough knowledge. Now, of course, you can't wait until you can have analysis paralysis where you get to, wait until you got 95% certainty. So there is a balancing act there.
That can be the challenge with perfectionism there.
Yeah, so you do have to balance that side of things. But a lot of, I think everything we do is a lot about communication. I think that's one of the biggest ones. I often find there's a good example of our two drivers we had at Techeetah, where we were racing in Santiago, and funnily enough, all of the TV screens and all the computers went down in our garage and two or three others, but not the ones that were being broadcast to the world. Okay. And we were getting these text messages saying, "What are you guys doing?" And we're like, "What do you mean, what are we doing? We've got a problem with the systems." Yeah. What we didn't realize was when the TV came back up and everything, our drivers had been fighting on track and hitting each other. And we didn't know that they were doing that. And so everyone thought we were a bit idiotic because we hadn't been doing anything. Yeah. And we quickly found out what had happened. We, of course, talked to both drivers and said, "What does it say on your dash? How many laps to go?" And they were out by one lap. And the one behind thought the one in front was slow. The one in front thought the other one was, "Why is he pushing me so hard? Because we've got an extra lap to do." Once they reset the numbers, then they calmed down and finished the race and won first and second. But it was pretty bad but that showed to me that one of the examples of communication, they just didn't know that the other person had the wrong information. As soon as we fixed that information, then it went back to being what they should have done. So that's my ultimate example of communication. That's definitely
communication, and I think it's a really good one as well on clarity over what you're actually trying to achieve, because we sometimes say in strategy it's the importance of being clear and a clearly communicated end goal. So for example, if you have let's take a Premier League footballer or a Premier League football team, and you have the striker who wants to win the Premier League, you have a midfielder who wants to make top 4 or now top 5 and make the Champions League, and you have a defender who wants to play in the Premier League, make a ton of money and have a good time. The way in which they train, the way in which they eat, the way in which they sleep, the way in which they compete, the way in which they go into that tackle on the pitch is going to be very, very different depending on their understanding of what does it mean to win? What are we also trying to do? And when you have two drivers on a track where one's thinking, we need to achieve this because this is what it's telling me I've got left in the race. You've got someone else thinking, no, we need to achieve this because we've got that left in the race. the way in which they literally operate is different.
Yes, and it's quite spectacular. So have a look at it on YouTube.
I'm gonna have a look at it on YouTube, and all's well that ends well as well, because you finished with a 1-2.
Yeah, exactly.
Last couple of questions, and very conscious of time as well. Is there a leadership, a lesson in strategy as well, that's cost you most dearly to learn?
That's an interesting one. I suppose I do think that sometimes you've got to go. Often I say everything's a process, and so sometimes I find that you have to kind of go through it to get to the other side. I do think that sometimes, if anyone ever asks me how long does it take to get something right, I usually use the 3 times. To say that it takes 3 times to get it perfect, or not perfect, but I also think about the Pareto principle. 20% of the effort gets you 80% of the way, and then the last bit's started to get quite hard. So pushing everything into a process, I find that when there's any disagreements, or people aren't sort of getting on, or don't think that this person's wrong and that person's right, kind of thing, you push it through a process and you start to say, how do we get here? What's happening? You push everything through a process. I find that helps to get you to the other side. But sometimes going through that, experimenting can get a bit bumpy when you say, look, we're not going to get it right first time, but let's go down that direction. I suppose that strategy works sometimes, but the first time you maybe get something wrong, it can be a bit disastrous, and then everyone sort of starts to go, oh, we're not going to get there. So I think when I worked for Arrows, I remember with my boss at the time, you'd say, how many times do I get to get this right? And sometimes he'd say, first time, every time. And I'm like, okay, that's going to be a bit more difficult. Sometimes you got 2 times. So you got, okay, we can try this level first. And then if it doesn't work, we can go back to the other one. Or maybe sometimes you might say 3 times, go on. I think it'll take you first time to get it close, second time to get it too far, and then the third time to get it right. So there's sort of that sort of pushing things into a process. I know I haven't quite answered the question completely, but that things have gone wrong along those way.
Yeah, and we've all seen the videos of the YouTube compilations of SpaceX rocket boosters from 10 years ago or 8 years ago to where they are now. Yeah, and the failed compilations that are all part of the process.
Yeah.
For those that lead in complex environments and complex businesses, and with the world in which we live now, which is very volatile and complex and uncertain, is there one piece of advice that you would give for those that are leading in that environment?
I'm a big fan of the scenario analysis. So that's the Shell one that you obviously do, I'm sure, a lot.
A little bit.
Based on what Shell used to do. When COVID came along, we didn't know what was going to happen to motor racing. So we were trying to all figure out how to plan for the future, for example. And what we find in sort of going to the next race, the planning, the looking through the scenarios of what could happen, a good case, a bad case, a middle case, and being ready to react to one of those possibilities. The more preparation you can do, the better. And I think that plays out in so many ways. So I'm a big fan of even if you don't go through the full kind of Shell scenario analysis, at least trying to plan for eventualities certainly makes it, I'm not going to say easier, but certainly you can hopefully don't get surprised by so much. So I think that's important, so that when you arrive to work on Monday and there's a panic, hopefully you've thought through what could go wrong. So you don't have to do every single thing, but certainly knowing if this happened and that happened, what would we do? If this happened and that happened, what would we do? Yeah. And base it on some history. One of the things in motor racing you're always doing is, will there be a safety car? Yeah. will there be a red flag?
Will it rain?
How will it rain? Which has happened the last couple of races. And what will we do if all those 3 things happen? Yeah. And if they don't happen, what do we do as well? Yeah. Which didn't know safety car in the last race, but it did rain. So even just knowing some of the big parameters and being reasonably prepared is so much better than just turning up and going, I wonder what will happen today.
An effectively executed pre-mortem should hopefully make the post-mortem less painful.
Yes.
Less painful.
What
definitely.
did we not get right? What did we do wrong? What would we do better? Yeah. And then saying, okay, next race, we're more planned, we're more ready.
Exactly.
Yeah, it never stops, by the way.
No, that's the fun. That's the fun of it, though, right?
Yeah, exactly.
Well, look, really, really appreciate the time today, Mark, and fantastic to speak. Just to finish up, I've got written down the variety of areas that you're working across, but I think I won't do it justice. So for those that want to keep track of what you're doing, what the team is doing, and other areas as well, where can they do that?
Yeah, so Lola Cars is where we're doing the racing with Lola Yamaha Apt. You'll find us on social media and on websites. And then with autonomous vehicles, it's oxford.tech. So you'll see the two different places we're playing.
Fantastic. As I said, really appreciate the time. Really fascinating conversation, and look forward to hopefully chatting a bit further soon.
Thank you.
Thank you.